Hello, my name is Pamela and I'm a math tutor. Today we're going to be talking about how to find limits given the graph of the function. Okay, let's start with this example. First of all, what you need to know is the difference between finding limits and finding images. So let's start with finding an image. Let's find the image of x equals 4. So in order to find an image, we just have to follow 3 simple rules. We're going to find the image when x equals 4. So for that, we are going to find the value 4 in our x-axis. So here we have our x-axis, and the value 4 is this one that I just underlined. That's our first step. Our second step is going to be drawing a vertical line over that value x equals 4. So if we draw a vertical line, we realize that that line is going to hit our graph, our curve, right here. So the third and final step is going to be to draw a horizontal line, and you draw that line until you hit the y-axis. When you hit the y-axis, you just have to read that value in the y-axis, and you realize that the image of 4 is 1. Okay? Now the big difference between finding images and finding limits is that when you find a limit, you do not care how much is the function in exactly that point. What you care is the behavior of the function around the given value of x. Let's do, for example, x equals 2. Let's find the image first. So the first step is that one that I already did. Find the value of 2 in the x-axis. Second step, draw a vertical line over that value and go up until you hit the graph. We are hitting the graph right here. We are not hitting the graph with our vertical line up here, because right here there is a blank dot, a white dot. That means there's no graph in there. Our graph is actually down here. So our vertical line is hitting the graph right here. So third and final step is to draw the horizontal line right there to read the value of the image in the y-axis. So the image of 2, it's again 1. Okay, so the big difference between finding limits and finding images, let's find the limit when x tends to 2. The big difference is that for limits, you do not care what the function does exactly in the value of x. You care how the function behaves around that value, okay? So we are going to follow the 3 steps to find the limit. First of all, you find the value 2 in your x-axis. Now, this is your x-axis, and here's your value 2. Next step, instead of doing your vertical line right over your value 2, we're going to do it a little to the left of that value, right here. Okay, so we do our vertical line. Okay, right in this picture, my vertical line is actually touching that this black dot, but it's not supposed to be doing that. That's just because the dot is too big. So that is not where the vertical line is actually touching the graph. The line is touching the graph right here. Right here. Okay? And again, my vertical line is inside of the blank dot because that dot is too big, but it's actually touching the graph right here. So the third and final step is to draw the horizontal line to read that value in the y-axis. And that value will be 2. Okay? So now we are going to repeat the process, but we are going to move a little bit to the right of the value 2 in our x-axis. So here's the value 2. We move a little bit to the right here, and we do our vertical line. That vertical line is going to touch our graph right here. Right here. And the third and final step is to draw the horizontal line to read what value is that in the y-axis, and that value is 2. So in this case, the limit and the image do not coincide. Okay. Now let's find the image for x equals -1. So the image. First of all, we find -1 in the x-axis is right here. Because we want to find the image, we are going to do our vertical line right over -1. And we notice that our line is touching our graph in exactly this point. So we do the horizontal line and read the result in the y-axis, and that will be 1. Now let's do the limit. Okay. For the limit, we are gonna move a little bit to the left of the value -1, and that's where we're gonna do our vertical line. Okay, our vertical line hits the graph right here, and now we do the horizontal line and we read in the y-axis that that value is 1. Now we're gonna do the same thing but to the right of -1. Okay, right here, a little bit to the right of -1, we're gonna start doing our vertical line. And that line keeps going until here, where it touches our graph. When it touches the graph, we do the horizontal line, and we realize that that value is around 2 in the y-axis. So, we say that the limit does not exist. Because the lateral limits are not the same. Okay. From the left, we were getting 1, and from the right, we were getting 2 for x equals 1. So in this case, the image exists, but the limit doesn't. Okay, if we do x equals 3, we realize that, first of all, there's no image for x equals 3. Because we're finding an image, we do our vertical line over that number, and our vertical line does not touch the graph because right there is a blank dot. If we do the limit, instead of doing our vertical line right over x equals -3, we do it a little bit to the left. Then we do the horizontal line, and that gives us a 1. And a little bit to the right, and that again gives us a 1. So the limit when x tends to -3 is 1, and the image does not exist. Okay. Let's look at a second graph. In this graph, we're gonna do something a little bit different. We're gonna find the limit when x tends to -infinity and to +infinity. So let's do -infinity first. Following our 3 steps, we will have to find -infinity in the x-axis. Of course, -infinity won't be in the picture, but we can pretend it's in the left end of our x-axis. So if we pretend -infinity is right here, we do our vertical line. That vertical line hits our graph right here. Then we do the horizontal line to read that value in the y-axis, and that gives us 1. So the limit when x tends to -infinity is actually 1. If we try to do the limit when x tends to positive infinity, this is what happens. So first of all, we find positive infinity in the x-axis. Let's pretend that's in the right end of the x-axis. So if right here it's your positive infinity, you do a vertical line, you hit your graph right here, and this could be a little misleading because now you do the horizontal line and the value you find in the y-axis is, let's say, 3, but that's not correct because actually right here is not your positive infinity. This value is actually, let's say, 5 or 6. So in order to be sure your answer is correct, I would recommend to extend your graph a little bit. Let's extend the x-axis, let's extend the graph, and now let's pretend the positive infinity is right here. So we do the vertical line, it hits your graph right here, and then we do the horizontal line, and that gives me some value right here. And if you keep extending the axis and keep extending your graph until you run out of paper, you'll realize that the more you move to the right of your x-axis, the larger, the bigger the value in the y-axis is going to be. That tells you that the limit when x tends to positive infinity is positive infinity. Okay, and that's the way you read limits out of a graph of a function, following the 3 steps you need to follow when you find images. Thank you very much.